In October of this year, astronomers discovered something unprecedented, an interstellar object passing through our solar system. They named it Oumuamua, which in Hawaiian means messenger or scout. Since then, it has been the subject of intense scientific speculation and debate. Its trajectory, elongated shape, and inexplicable behaviors made it one of the greatest enigmas of modern astronomy. Presently, because of the James Webb Space Telescope, we have the first real image of this interstellar traveler. Oumuamua looked like nothing we'd ever seen before. Unlike comets, it had no visible tail and no signs of outgassing. Unlike asteroids, its acceleration away from the Sun was unfathomable by gravity or known forces. Since its discovery, hypotheses have been put forward ranging from fragments of hydrogen ice to the possibility that it is a spacecraft designed by an advanced civilization. But no answer has been finalized to date. Launched in December 2021, the James Webb Telescope is designed to solve the deepest mysteries of the universe. Its ability to observe the infrared spectrum allows it to capture details impossible for other telescopes. When Webb turned its gaze toward Oumuamua, now much further from our solar system, it captured something amazing, the very first real image of this mysterious interstellar object. The image from Webb confirmed what could only be speculated before. Oumuamua has an elongated and asymmetrical shape, with a surface marked by grooves and craters, indicators of billions of years traveling through interstellar space. But what is most surprising is its composition, organic compounds on the surface and elements not commonly found in our solar system. This, of course, suggests that Oumuamua originated in a cosmic environment quite different from ours. One of the biggest enigmas of Oumuamua has been its unusually rapid acceleration as it leaves our solar system. Webb's observations have ruled out outgassing but have brought up new possibilities. One intriguing theory is that the acceleration could be caused by an exotic mechanism such as a light sail, a hypothetical technology that uses the pressure of light to move through space. Thanks to the James Webb Telescope's ability to analyze the light reflected by Oumuamua, scientists have managed to unravel the composition of its surface. The data reveal a mix of metallic and mineral compounds unknown in the solar system, along with traces of elements that could form some of the most complex organic molecules. One of the most fascinating findings is the presence of a material with high reflectivity, which could explain its unusual brightness, as well as compounds suggesting that Oumuamua may have formed in a young, dynamic star system. These discoveries offer key clues about the processes occurring in regions of the universe where matter is organized in completely different ways than in our cosmic neighborhood. One of the most recent theories suggests that Oumuamua could be a fragment of a planet destroyed by extreme gravitational forces. These forces, caused by a massive star or a nearby black hole, could have stretched and torn the planet apart, forming objects with unusual shapes. If this theory is correct, Oumuamua would be a survivor of a catastrophic event, carrying with it the history of a lost world. This opens up a new window to examine the evolution of star systems and how catastrophic events can give rise to objects that travel through the galaxy. The organic compounds found on Oumuamua's surface have led to speculations about its function as a carrier of life-building blocks in a universe full of possibilities. Could Oumuamua be a natural vehicle for distributing these molecules? This phenomenon, known as rising interstellar panspermia, suggests the possibility that objects like Oumuamua play a key role in spreading the ingredients necessary for life across the cosmos. Not only does this redefine our understanding of the universe, but it also makes us wonder whether our own existence could be linked to similar events in Earth's past. Oumuamua is more than an interstellar object. It is a time capsule that carries with it stories of cosmic events that occurred billions of years ago. Its study not only teaches us about its origin, but also about how star systems interact and evolve in the galaxy. In addition, the analysis of Oumuamua lays the groundwork for future missions designed to intercept and study these interstellar travelers, offering a new perspective on galactic dynamics. This discovery is a reminder that the universe is full of mysteries waiting to be discovered, and Oumuamua is just the beginning. It has not only challenged our scientific theories, but also our perception of our place in the universe. We are reminded of our status as a small part of a vast and immense cosmos where such events take place continuously, even far beyond our sight. If this object has been manufactured, it could be the first indirect contact with an extraterrestrial intelligence, a possibility that would transform our understanding of life and intelligence in the universe. Oumuamua has inspired, of course, a new generation of scientists and engineers to think beyond our own solar system. Projects like Breakthrough Starshot, which seeks to develop probes that travel at relativistic speeds, mark the beginning of an era of interstellar exploration. These future missions could not only intercept objects like Oumuamua, but also explore their characteristics and gather information that helps us comprehend and respond to the questions that still need to be answered. With each discovery, we move toward a future where humanity could not only observe the universe but also interact with it in ways we can now only imagine. Oumuamua, the interstellar messenger, is much more than an object that passed through our solar system. It is an open door to a universe full of possibilities and mysteries. These discoveries have changed astronomy and inspired questions about our origins, our place in the universe, and our future. As a result of the James Webb Telescope, we have taken another step forward in understanding what it means to be part of such a vast and complex universe. Oumuamua is a reminder that although we are small, our curiosity and desire to explore make us great. The universe invites us to dream, and Oumuamua is just the beginning of it. What other secrets await us out there? Only time, and our tireless pursuit of knowledge, will tell. As scientists continue to analyze the data from Oumuamua, a broader question emerges: how many more such visitors have passed unnoticed through our solar system? Until recently, our instruments were not sensitive enough to detect small, fast-moving interstellar objects. Now, with advanced tools like the James Webb Space Telescope and next-generation ground-based observatories, we may be on the brink of a new era in which interstellar objects are not rare anomalies but frequent messengers from distant corners of the galaxy. Future detection systems, such as the Vera C. Rubin Observatory in Chile, are expected to greatly increase our ability to spot such objects early, perhaps even early enough to mount intercept missions before they leave the solar system. If we succeed, we may one day collect physical samples from an interstellar object, holding in our hands matter that originated light years away from Earth. The implications of this are staggering. Analyzing the atomic structures, isotopic ratios, and chemical compositions of such samples could reveal entirely new forms of matter or life-enabling chemistry, not just unfamiliar to our solar system, but perhaps completely unknown to our understanding of physics and biology. Moreover, if Oumuamua is indeed artificial, or even partially so, then we must entertain the profound possibility that intelligent life exists elsewhere in the universe, and that it has developed technologies capable of interstellar travel. Such a revelation would not only change science, it would change civilization. Governments, private organizations, and scientific institutions around the world are beginning to pay more attention. Initiatives like NASA's proposed interstellar probe, and renewed interest in missions capable of long-duration travel, reflect a shift in priorities, from purely local exploration to galactic engagement. Public interest has also surged. Oumuamua has become a symbol of humanity's longing for connection beyond Earth, a silent echo from the stars that stirs both scientific rigor and poetic wonder. It challenges us not just to ask what is it, but who are we, in a universe where such things are possible? We stand at the edge of a horizon where science, philosophy, and imagination converge. If Oumuamua is the first, then it will not be the last. As our tools sharpen and our reach expands, more messengers will follow, each with their own story, each a fragment of the universe's deeper narrative. In the end, the greatest message Oumuamua may bring is this: the universe is not silent, and we are not alone in our search to understand it. Knowledge will inform us now. Please hand over your thoughts in the comments box. What do you believe Ouma is actually telling us? If you want to continue exploring the mysteries of the universe, don't forget to sign up to the channel and activate the notification bell. I'll see you in the next video. Thank you so much for watching. Oumuamua's discovery has not only opened a new chapter in observational astronomy but has also challenged long-held assumptions about the boundaries of our solar system. Astronomers have long believed that the space between stars, interstellar space, was too vast and hostile to allow for the frequent passage of solid objects. Oumuamua forever altered that perspective. Since its passage, scientists have intensified efforts to detect similar objects. In fact, new initiatives such as the Vera C. Rubin Observatory's Legacy Survey of Space and Time, LSST, aim to identify fast-moving interstellar objects as they enter the solar system, giving humanity a chance to study them close up, or even catch them with spacecraft. With this growing capability, Oumuamua may be remembered not just as a mystery, but as the beginning of many such messengers from above. The consequences extend far beyond astronomy. The chemical compounds detected on Oumuamua's surface suggest that life's essential ingredients, organic molecules, can form and exist in a variety of cosmic environments. This supports one of the most profound ideas science has ever considered, that life may not be unique. If Oumuamua-like objects travel to Earth between star systems carrying complex molecules, they could be the seeds of life, sown far and wide across the galaxy. Some researchers even make technological speculations, that we might one day detect technosignatures, indications of advanced technology in future interstellar visitors. If an object's characteristics are inconsistent with natural formation, such as consistent, precise geometric shapes, non-gravitational propulsion, or unusual materials, it could trigger a new era in the search for extraterrestrial intelligence. Yet for all its scientific value, Oumuamua also touches something deeper, our imagination. It reminds us how little we actually understand about the universe, and how each discovery, no matter how strange, pushes the boundary of what we consider possible. In response to this mystery, several space agencies and private organizations have begun planning missions that could one day intercept or catch up with interstellar objects. Projects like the proposed Project Lyra, developed by the Initiative for Interstellar Studies, are exploring the use of solar sails or high-velocity propulsion to chase Oumuamua, or its successors, into deep space. These missions could allow us to analyze the composition of such objects directly, perhaps even retrieve samples. A sample return mission to an interstellar object would represent one of the most ambitious endeavors in human history, providing us with tangible evidence from another star system and potentially rewriting everything we know about the formation of planets, stars, and even life. Moreover, we may be influenced by Oumuamua's legacy to design future telescopes and instruments optimized for tracking high-speed interstellar objects. Such capabilities could become common in the coming decades. These upgrades would not only help us detect interstellar visitors more effectively, but also strengthen our planetary defense capabilities. In many ways, Oumuamua is a cosmic invitation, an opportunity for humanity to look beyond its own celestial backyard and embrace the reality that we are part of a much larger, dynamic, and interconnected universe. This is more than just a rock or a spacecraft. It is a symbol of exploration, of mystery, and of the endless questions that still await us among the stars. As we stand on the threshold of a new cosmic era, inspired by Oumuamua's fleeting visit, humanity is faced with a choice: to retreat into the comfort of the known, or to venture boldly into the unknown. The tools at our disposal, telescopes that can scan the sky with unprecedented speed, spacecraft capable of high-velocity maneuvers, and advanced data analysis powered by artificial intelligence, are now catching up with our curiosity. The stars are no longer distant dreams, they are becoming data points, destinations, and domains of discovery. But with this potential comes responsibility. We must ensure that the search for knowledge is coupled with respect for what we find. If we encounter signs of life, be it microbial, molecular, or mechanical, we will face questions that transcend science, ethical, philosophical, and even spiritual inquiries about our place in the cosmos. Oumuamua may have passed us by silently, without answering the many questions it raised, but it has done something even more powerful. It has awakened a deeper hunger for understanding. It has reminded us that the universe is not static or silent, it is alive with motion, mystery, and meaning. Every night sky we look up to is no longer just a backdrop to our lives, but a frontier. And every strange object, every anomaly, could be a whisper from a far-off world, or a shout, daring us to listen more closely. As more missions are proposed, and more objects are discovered, we are writing a new chapter in the story of exploration. It is no longer just the story of where we come from, but of where we are going. Because in the vast silence of space, perhaps the most profound echo we will ever hear is our own.